Okay, class, so we're on page 632, and we're doing questions 3 through 8 right now. And they want us to find the value of x. Well, here I have two chords which are inside the circle. And if you remember, we said that if we multiply the two parts of the chord together, they should be equal to the product of the other two parts of the chord multiplied of the other two parts of the chord. So this is x and this is 15, so I'm going to multiply the x and the 15, or the 15 and the x, and that should be equal to the product of the 18 times the 10. 18 times 10, so 15 times x is 15x, 18 times 10 is 180. Obviously, we're going to divide both sides by 15. When I do that, x is 12. So what happens here is that this little portion right here of the chord is 12. Now when you add them, yeah, 12 and 15 is 27, and 18 and 10 is 28. Remember, we never said they were congruent. We're just looking for this part here. And if you multiply them together, their products, if you multiply the parts together, the products should be equal to each other. Number 4, we have a situation here where we have two secant lines. And if you remember, the way that we said that is we take the outer portion times the entire thing. So my outer portion is 12. My entire thing is x here, so it's 12 times x. Over here, my outer portion is 15, and the entire thing is 15 plus 25 is 40. So it's 12 times x is 12x, 15 times 40 is 600. Obviously, we divide both sides by 12, and x is 50. So the entire length of this segment here is 50, and then we could find this little part here if they were asking that, but what they wanted was the entire thing, which is 50. Number 5, again, they want to know what is this chord right here, right? Remember, we take the outer portion, which is 6, times the entire thing, which is 16. And it should be equal to x, excuse me, not x, 8, the outer portion, which is 8, times the entire thing, which is 8 plus x. And I have that here. So I have 6 times 16 is equal to 8 times 8 plus x. We're going to distribute here. By the way, 6 times 16 is 96. 8 times 8 is 64. 8 times x is 8x. After that, we can see here that we subtract 64 from both sides. That's equal to 32. This cancels out. The 8x comes down. Obviously, we divide both sides by 8, and x is equal to 4. So this little portion right here is going to be 4 units long. Number 6. Again, well, no, number 6 is a little bit different. Number 6, I have a secant line, and I have a tangent line. And if you remember in the rules, we said that since we don't have anything to multiply the tangent line with, we square it, we multiply it by itself. The secant line, we treat it just the way we treat all the other secant lines. It's going to be the outer portion times the entire thing. So I'm going to square my tangent line. That gets 4 squared. And then it's going to be equal to 2 times the whole thing. It's going to be 2, and the whole thing is 2 plus x. So 4 squared is going to give me 16. I'm going to distribute this 2. 2 times 2 is 4. 2 times x is 2x. Now I have an algebraic equation. Subtract 4 from both sides. It gives me 12. These cancel out. The 2x comes down. Obviously, I divide both sides by 2, and x is equal to 6. So this portion right here is going to be 6 units long. Number 7, again, I have the same scenario. I have a tangent line, which is x units long. This is 4 and this is 8. I don't have anything to multiply my tangent line with, so what do? I square it. It's going to be x squared. Over here, my outer portion is 4. The entire segment is 9. So it's going to be 4 times the whole thing, which is 9. So x squared is equal to 4 times 9. X squared, 4 times 9 is 36. I don't want x squared, so what do? I take the square root of x squared and the square root of 36. That's going to give me x, and the square root of 36 is 6, because 6 times 6 is 36. Number 8, we're not going to do number 8. Sorry if I assigned that one. Let's move on to questions 10 through 15. Question number 10. Again, we have chords inside of a circle. They're asking for the length of this part right here. Remember, we said that if we multiply the two parts of a chord together, they should be equal to the product of the other two parts of the chord together. So if I take 9 and multiply it with x, it should be equal to the 15 times the 12, or the 12 times the 15. I have that here. 9 times x is 9x. 12 times 15 is 180. Obviously, I'm going to divide both sides by 9, and when I do that, x is going to come out to be 20. Number 11. Again, we have two secant lines, and it looks intimidating, but just take it step by step. You know what the rule says. The rule says you take, let's start off with this part up here. The rule says you take the outer portion, which is x units, and you multiply it times the entire thing, which is 45 units. So you're going to have x times 45. Over here, we have 27, which is the outer portion, and the entire thing is 50. So we're going to multiply 27 times the entire thing, which is 50. So here I have x times 45 is equal to 27 times 50. I distribute, that gives me 45x. These two multiplied gives me 1350. Obviously, I divide both sides by 45, and x comes out to be 30. And let's take a look here. Number 12. Number 12, I have a tangent line. I have a secant line. I hope by now we realize that when you have a tangent line, you square it. And here we have a secant line, so it's going to be 9, the outer portion, times the entire thing, which is 9 plus 7, which is 16. So it's going to be 9 times 16. X squared is equal to 9 times 16. When I multiply 9 and 16, I get 144. Obviously, we're looking for x. We take the square root of both sides, and the square root of 144 is 12. So x is equal to 12. So this tangent line here is 12 units long. Let's take a look at number 13. Again, for number 13, I have two secant lines. So we know what to do there, guys. We take the outer portion, which is 12, and we multiply it times the entire thing, which is 35. 12 plus 23 is 35. So it's 12 times 35. Over here, my outer portion is 15. There it is. And I'm going to multiply that times the entire thing, which is 15 plus x. So 12 times 35 is 420. When I distribute the 15 here, gives me 225 plus 15x. I'm trying to solve for x. Subtract 225 from both sides. 195, this cancels out, is equal to 15x. I'm obviously going to divide both sides by 15. When I do that, x comes out to be 13. So this chord right here is 13 units long. Number 14. Again, they're inside my circle, so I know that I multiply the parts of the chords. So I know if I multiply this x part here with the 4, it's going to be equal to the 16 times the 7. So here I got 4 times x is equal to 16 times 7, which is 112. Divide both sides by 4, and x is 28. Question 15, the same scenario again. So I'm going to multiply the x here times the 24, which gives me 24x. I'm going to multiply the 17 times the 12, which gives me 204. I'm going to divide both sides by 24, and x is going to be equal to 8.5. And those are the questions on page 632. Now let's go to the following additional questions on the back that we had here. Okay, simple enough. Again, they're asking me for the length of this chord here. I think by now we should know what we're doing, right? We're multiplying the two parts. So we're going to get 7.5x. Over here we got 5 times 12, which is going to give me 60. Divide both sides by 7.5, and x is equal to 8. So this part of the chord here is 8 units long. Number 2 was a little tricky, but it was actually just a refresher question about something we've discussed before. If you look here, they tell you that arc WX is 25. They tell you that arc XY is 40, and that YZ is 25, right? And I actually highlighted them here in blue. Now I want you to notice something here. Do you see line WY? Chord WY. You see how big it is? It's 25 and 40, so it's 65. The chord WY makes an arc that's 65 degrees long, right? But then look at chord XZ, right? XZ in green makes a chord that's 40 plus 25. That's also 65 degrees. Well, if these two chords are making arcs that are the same size, what do we know about the two chords? What do we know about this blue chord and this green chord? If you remember, the rule says that if the arcs that they create are congruent, then the chords themselves are congruent. So WY is congruent to XZ. And here, in this question, they tell you that WY is 24 centimeters. Well, if WY is 24 centimeters, then XZ is also going to be what? 24 centimeters. So that would be choice B. Let's take a look at this question here. Next question. Okay, they give me some information about the diagram, right? And in the diagram, they tell me, what do they tell me? They tell me that AB is 20, okay? So the entire length from there to there is 20. They tell me that A to E is 12, so they give me that. And here's the part that I want that you should notice. You should notice that you have a circle here, right? But look at that. When I cover that, what kind of lines are these right here? Well, these are two tangent lines coming from an external point. And if you remember, we said that tangent lines coming from an external point are congruent. So if this is 12, this is also 12. Matter of fact, all of these are tangent lines coming from external points. So they're all going to be congruent. Again, here I also have an external point, two tangent lines, so these would obviously be congruent as well. So they tell me that the whole thing is 20. They tell me that AE is 12. They tell me that C to F is 15. And they want to know what is the length from A to C. They want to know what the length from A to C is. Well, now since I know these are tangent lines and I have all that information, well then from A to C, all I have to do is add 12 plus 15, which is going to give me 27. Let's take a look at number 4. Question number 4. Same type of question. Same type of question. They tell me that AF is 6. Okay, so there I highlighted in blue, AF is 6. But I know that these are two tangent lines to my circle. Yeah, it's a triangle, but they tell me that the lines are tangent to the circle. So then I know that these are both going to be 6 here. They tell me that CD is 5. Well, I got two tangent lines, which should be congruent, so this is also going to be 5. And they tell me that BE is 4. So I have two tangent lines here, which are both going to be 4. They want to know what the perimeter is. Well, I know this is 6 and 4. This is 4 and 5 and 5. I filled it all in. This side here is 10. This side here is 9. This side here is 11. And when I add them all up, I get, I believe it's 30. 11 plus 9 is 20, plus 10 is 30. So the perimeter is 30. Number 5, okay? Well, they want to know what is the measure of angle ACB. Well, I got two arcs here across from it. So I know if I add them and divide by 2, I'll get that angle. 86 plus 68 is 154. Divided by 2 is 77. So this angle here is 77 degrees. And this one here is also 77 degrees because they're vertical angles. Although they just wanted this, I just want to just point that out. Next question. Question number 6. Well, in question number 6, they tell us that arc RT is 80 degrees. Well, we know that a circle has 360 degrees. So if I take 360 minus 80, I get the rest of the arc. I get the rest of the arc, which is 280 degrees. So now this arc out here is 280, and this arc in here is 80 because they gave me that. Now I want to find the measure of angle S. That is, the measure of angle RST, or just angle S, which is the vertex. They want to know the measure of this angle. Well, the angle's on the outside of the circle. So what do we do with these two arcs? We subtract them. So 280 minus 80 is 200, divided by 2 is 100. So angle RST is 100 degrees. And finally, question number 7. They give me a diagram here. They give me, they tell me that this is a tangent line. Doesn't look like it because, it keeps going. Actually, it does look like it. It doesn't stop, but it is a tangent line because they tell me that here. I know this is X. They give me a secant line, and by now we should know what to do. We're going to take our tangent line, we square it, and that's equal to the exterior of my secant line, 4, times the length of the whole thing, which is 9. So we're going to get X squared